Question 11 is about classical curves, or also known as special type of polar graphs. Now here, these are some of the basic things you should know, the standard forms and how the curve looks like, and then we can easily solve the problems. Here you can see the circle. These are circles, right? It's either right or left. That's in the horizontal axis or the vertical axis. If it's in the horizontal axis, it's cosine. If it's at the right, it is a cosine theta, but a is positive value. It'll be plus. Whereas if it's left side, it's minus. Here, it'll be minus 2 cosine theta or something like that. So that's how we denote it. Whereas if it's up and down, it'll be sine and sine. So r equals a sine theta. When it's up, it's positive. Down, it'll be negative. And then we have over here Lemasson's. So you can see this over here. There's a loop here. Whenever there's a loop, the standard form is similar to this: a plus a minus b or a plus b. Now there is sine and cosine. If it's on the right side, it is cosine. Down or up, it'll be sine. And since it's in the electronic part, you just have to figure out the correct option. So you don't need to go in depth of memorizing all the things. Just remember how it looks like. So now if it's at the left side, you can see over here, it'll have minus here. See, even over here, down will be minus b sine, left side minus b cos. And then if it's up, it'll be plus and it's sine. Why? Because it's up over here, down is sine, but it's minus. The right will be positive, left will be negative. That is all a pattern. Now we call them cardioid if it's in such form. Here, dimpled Lamasson, and then convex Lamasson, and over here in a loop. Now then we have roses. Depends on the number of petals. If you see here, this is how many odd number, 3 petals. If you count over here, there are 5 petals. Then this number here, n, will be 5. Okay? Whereas over here, if there is, say, even number, let's start with the thing, n2. You can count over here, there are 4 petals. But if it's an even number, there's a catch. N will be 2, but the petals will be twice than that. If n is 2 here, say you have 3 sine 2 theta. Then if it's in the shape of rose, you won't have 2 petals, you'll have 4 petals times 2 for even numbers. Even over here, this n is 4 theta, but you will have 8 petals because 4 is an even number. Whereas if it's odd number, it remains the same. Then we have lemniscates. Over here, you can see this is a lemniscate wherever it's on the axis. See, on this horizontal axis, it's cosine, whereas if it's not on the axis, then it is sine. And these are this is the last one, spiral of Archimedes. And over here, you can see it's a spiraling one. Now let's look into the problems. Here we need to write the equation for this graph. You will have 4 options and just figure out which is the correct one. I know something, a radius is how much? 3. It has something to do with 3. And then, sorry, not the radius, the amplitude. It starts from 0 to 3, right? This is between 2 and 4, it's 3. And then it's up. So it's sine. It's in the vertical axis and its upside will be positive sine. So it's 3 sine theta, positive answer. Now what about this one? If you see at this one, it's lemniscate. Let's write the standard formula because it has to do with r squared a squared sine 2 theta. Why did I write sine here? Because it's not like this on the horizontal axis. If it's not on the horizontal axis, you just take it as sine. Just look at this one, whether it's there or no over here. And then let's substitute. Now what is the a value here? It's 1, 2, 3. It's not just 3. A value is 3. 3 squared sine 2 theta. So it'll be 9 sine 2 theta. That will be the answer. This is lemniscate. So in your options, you must have r squared and 9. So it's easy to figure out. Just count the amplitude and see which has 9. If anything doesn't have 9, you can ignore it. Then you can see whether it's sine or cosine and figure out the answer. So over here, looking at the options, see, this is the answer, right? How would you see easily? 4. Okay, let's count the petals. It must be 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes. You will have to choose the correct option. So first count the petals. You have 8 petals. This is a rose. So see which has 4 theta. So if anything that doesn't have 4 theta, that's the wrong answer. Only one or maybe 2 options will have 4 theta. So now look over here. Is it on the horizontal axis? Yes, over here you can see it's on the horizontal axis. So it's cosine, not sine. If it was not on this, see this horizontal axis there, if it was not over there, then it would have been sine. What is the amplitude? It's 3 here. That's it. Similarly, please do go through these problems. I'll just quickly run through them. Now over here we have only 3 petals, so it should be 3 theta, and it is not on the horizontal axis. Can you see here? There's no horizontal axis, so it's sine, and the radius is 4. Over here this is circle. Left side will be cosine, but it's minus 2 is the amplitude, cosine theta. And over here again lemniscate. A lemniscate will be having r square equals, now what is this? 2. Amplitude is 2, but it will be 2 square is 4. Since it's on the axis, it's cosine 2 theta. We have a different type of problem now. It's about a fan. A ceiling fan has a central motor with 5 blades that each extend 4 units from the center. The shape of the fan can be represented by a rose curve. Now they have told it's a rose. So if you remember, r is equal to a sine n theta, depending on the number of petals. It can also be cosine, right? Because see, now they have just told it's a rose curve. We cannot be 100% sure whether it's, on the horizontal axis or no. So we just write both of them, okay? It's cosine n theta. So now what is n? 5 blades, petals, right? There are 5, so I can directly write it's phi theta, phi theta. And it's sine or cosine. Now what is it extends 4 units, means this is 4 units long. The petals are 4 units, so it's 4, and over here also 4. That is the answer. So this is it. It'll be this or this. You can choose any one of that because that can be sine or cosine. It'll just flip, but as long as these conditions are satisfied, all these conditions are satisfied, so that's the answers. Now then sketch the graph. We need to sketch the graph. Now sketching graph, you can do it in calculator as well directly, or you can just look over here. There are 5 petals and this is extending towards amplitude of 4. Yes, that's it. That's the graph. Now here you can also do it by the table method. Since it's an electronic part, you do not need to do this. You can just figure out the correct graph. But remember, in your exam, you can have, there are 2 graphs over here. So this or this. So both are possible. When it's sine, it doesn't touch the horizontal axis. Now here, okay, we need to prove. Now this may not come for the electronic part because these are proving problems. But let's prove this one anyways. Let's see what they have told. We need to prove the symmetry along the line. Theta is equal to pi by 2. Pi by 2 is 90 degrees. Okay. Now imagine over here. We need to prove the symmetry. Imagine, let's take a point like this. If it's symmetrical means like a parabola. You know parabola, right? Along the x-axis, the y-axis, it's symmetrical. This point and this point have the same y value. They're all symmetrical like this, isn't it? So same way, if I take this point, the y value is say phi here. On the other side, along this, if I just extend it, it's the same x value over here. Imagine this is 4. It's not to the scale. If I take minus 4, this must be phi itself. That is the concept. Now it's not about x and y coordinates. We are dealing with polar coordinates, right? So here imagine the degree theta is 45 degrees. So here what will be the answer? It will be 180 minus 45, right? So it will be 135. Basically this, and from here to here, it's 135. How do we get it from the second quadrant? It's always, how much is the axis here? It's always pi or 180 degrees minus this theta value. That is how we find anything from this left side. Or you can take it as pi minus theta. So all we do is, since over here theta is given radians, we need to have 2 points, say r and theta. Radius over here I've considered as phi. Imagine r and theta, and the points r comma pi minus theta must be equal. So just substitute over here and we will check, because r and theta is already there, right? Now instead of theta, I will put 3 plus sine. Theta becomes pi minus theta. You might have realized this sine pi minus theta is in the form of sine a minus b, isn't it? So we need to write this formula. It's sine a cos b minus sine b cos a. In the next problem, I'll just write the 4 formulas, but now I'll just substitute and solve. Here, it'll be 3 as it is. Now this one, you will have to apply sine pi, that is sine a multiplied by cosine theta minus, sorry, yeah, it's minus because the minus. If it was plus for sine, it's just plus. So it's very easy to remember. Then we start with sine b, that is sine theta multiplied by cosine pi. Now this all over here. Now let's try to solve how much we can. What is sine pi? Pi is 180 degrees. Sine 0 is 0. Sine pi is also 0. So it will be 0 here. So that is gone. This part. Minus. What about sine theta cos pi? Cos pi is 180 degrees. I mean 180. Yes. It starts with 1 and it becomes minus 1. Why? Because cosine 180 equals, if you just put in the calculator or you put pi, it'll be minus 1, isn't it? The graph starts from here. So this is minus 1. So now here what happens is we have minus 1 multiplied by minus, it'll become plus sine theta. So it'll be 3 plus sine theta, that is equal to r. Is this the same question? Absolutely. So if we apply these conditions of symmetry over here, symmetric about this line, we will definitely get the same answer, right? So that means what? Yes, they are symmetrical. So that's the thing. So this is how we solve it, but this may not come because this is electronic part. You might be asked the other questions which you solved previous to this. Now I'll just write the formulas over here. Sine a plus b, sine a minus b. Then I'll do the cosine because these are the easiest. I personally feel these are easiest. You start with sine a cos b. Don't write sine. Whenever this sine and sine cannot be together, then since it's plus, you write plus. Again, start with always sine first, but now this time the second value, that is b cos a. Here as well, sine, cosine, sine, cosine. What do you start with? A, B, A, B. So it's so simple. Only the thing is it's minus here. Whereas what happens in cosine A plus B and cosine A minus B? Now in this case, you have to write like this. Cosine is the first one, right? You always have to start if it's sine, sine, but next can't be sine. Sine, sine cannot be together for sine functions. Whereas cosine will be just cosine, cosine, and I'll write the signs in a while, and it'll be sine and sine together. Only when it is cos A plus B. So it's sine and sine. Now what happens here? See, you start with A, B, even over here it's the same thing, A, B. Down as well, it's A, B, A, B. But what is the difference? If it's plus here, the minus sign is there. If it's minus, it's plus. The signs are inverted. It's like kind of flipped, rather than being plus, plus. If it's plus, it's minus. Minus becomes plus. So that's the thing. These are the formulas. You can just take those down. Just remember how to write any of those formulas. You can just take some time, think, and you can get the formula expansion. Now here they have told it's symmetric about the pole. So that means pole is the center, it'll be r minus r theta r comma theta. Why? Let me just show you. So this is the pole, right? So imagine I have this point over here. So symmetry along the pole means just extend it in the opposite direction, right? So if r comma theta is there, the opposite direction, theta will be the same thing, but your minus r comma theta, the r value becomes minus, isn't it? So that's the thing. And because you've put minus over here, it'll be easily squared. Similarly, go through these problems. These are proving problems. All the proofs are over here. This one as well. Over here, you can see all the steps are there. And okay, now we have one more real world problem. The shape of a certain type of a clover can be represented using a rose curve. Write a polar equation for the clover if it has 5 petals with a length of 2 units each. Now a value is 2, petals are 5, it's odd number, so it'll be 5 theta. So it's very simple, right? Now it will be either sine or cosine. We have done the similar one before. N is 5 theta, 5 theta. What is the length over here? A value is 2 and 2. Since it's just specified, we don't know exactly which is touching the horizontal axis or no, we take both the answers. If it's 4 petals, now here 4 petals means it is an even number. So n value will be half of it. 2 theta will be the answer. See, it's 2 theta, 2 theta. Why? Because petals will be half of this. And then this length doesn't change. It'll be just 7. Now it's 8 petals again, it'll be 4 theta. Half of 8 is 4 theta, and 6 cos and 6 sine because the length is 6. That is the end of question 11. Just remember the special type of curves. Understand what is rose, what is lemniscate, what are circles. Then you can easily figure out the correct answer.